This is the second in a series of video-based lessons that will introduce the basic database lingo and describe several features of a modern database management system. We begin with a motivating example, which will give you an understanding of how the database thinking evolved over time. We then provide a concise definition of what a database is and examine a number of important features of modern database management systems. This material is covered in Chapter 1 of our textbook. We begin with a simple order management system that performs three basic tasks. 1. Sales takes customer orders. 2. Fulfillment assembles and ships orders to customers. And 3. Billing invoices customers. Under traditional file-based approach, think spreadsheets, each of the three departments handles appropriate entries and creates reports separately. Each department defines and uses their own files, stores them on their own servers, with the required data definition by personnel of that particular department. In addition, any customized application programs are designed based on those file definitions. Data definitions, for example, customer names and addresses, are not necessarily the same in all three departments. So what are the problems with a file-based approach? Because data is isolated between different departments, and within departments, the data is spread out over a number of different files, it is nearly impossible to meaningfully link those files to perform queries and create reports. Data is also duplicated across the departments as well as across different files within a department. There is a high possibility of inconsistencies in the data. For example, a customer address change might be recorded in the sales department but not fulfillment. The order might be sent to an incorrect address. Finally, in the definition of data changes, application programs need to be If the definition of data changes, application programs need to be modified to reflect all those changes. Database approach provides an integrated view across the three and other departments by providing a centralized approach to managing all the data necessary to perform the required business functions. Each of the three departments are still performing the same functions, but are now using a single data management system, single physical storage, and a structured query language, SQL, designed to perform all the needed tasks efficiently and correctly. So what are the advantages of a database approach beyond the ones already mentioned? There is much less redundancy in the data. There is a single customer name and address available to all three departments, which means the data is shared throughout the entire organization and possibly even with external parties. The application programs now have the data separated from the functionality. This is called a three-tier client-server architecture and will be discussed in the next video. The SQL is used to query the database, and reports are easily created based on those queries. Because of this single version of the truth, the meaning and value of the data is consistent across the organization. If customer address changes, it does so in one place, and the change is instantaneously available to everyone. Ever since the transaction processing systems became the norm in the 60s, the problems with file-based systems described before became more apparent and led to the development of relational databases in the 80s that are still the norm today. Other, more advanced database types, such as object-oriented and NoSQL databases, better equipped to deal with more unstructured type of big data, are becoming increasingly popular today. Even so, the basic relational database principles, together with the power of SQL, are still the cornerstone of every database management system today. Business-driven definition of a database is a set of technologies that manipulate and summarize data, retrieve information, i.e., manage data and produce useful information. This information allows a business, like our sporting goods retailer to be introduced shortly, to make better decisions ranging from accurate billing, purchasing, and fulfillment to analyzing data for customer purchase patterns and insights on customer satisfaction. A more techie-driven definition of a database is an organized collection of persistent data that can be shared and is logically related. The three key attributes in this definition are: 1. Persistent. Sporting goods customer order and product data reside on a dedicated server. 2. Shared. Sporting goods data can be accessed across the entire organization and viewed from the outside. And 3. Related. Sporting goods customers, orders, and products are related in a set of business transactions such as customers place orders that contain products. Here we show how business operations, such as placing and fulfilling orders and processing bills and payments, are supported by a set of entities: customers, orders, products, and relationship between those entities, such as customers, order, products, that define a database system. This example brings us to another technology-based definition, this one of a database management system, or DBMS. A DBMS is a set of software components that support: 1. Data acquisition through user entry forms, 2. Transformation by performing required calculations, 3. Retrieval of information through queries, and 4. Dissemination of the results through periodic and/or ad hoc reports. The two somewhat dated surveys show different views of DBMS market share. The pie chart on the left shows Oracle, Microsoft, and IBM as leading providers of enterprise-based solutions. Interestingly, the bar chart on the right shows that MS Access, Microsoft Access, a desktop rather than enterprise-level solution known for its simplicity, it's still used extensively today. This chart also shows that more advanced big data solutions such as NoSQL and MongoDB still have ways to go.